Hello everyone, in this video we'll be solving problem 258, add digits. The problem statement is, given the integer num, repeatedly add all of its digits until the result has only one digit left and return that one digit. In example number 1, the number that is given to us is 38. If we add the two digits with each other, we'll get 11. As this number is still two digits, we'll add 1 and 1, giving us the result of 2, which is our output. In example number 2, when the input nums is given as 0, the output will be 0 because there is nothing to add and it is already a single digit number. This is also called as digital root, where we add all of the digits in the given number and represent it with a single digit number. One follow-up that is given to us is if we can solve this problem without a loop or recursion in O of 1 runtime. Let's switch to whiteboard and discuss the solution, starting with the naive or a brute force approach followed by an optimized one. In a simple brute force approach, we'll start iterating through all of the digits in the given number, add them up, and whatever result we get, we'll check if it is a single digit. If it is, then we'll return the value, or else we'll repeat the same operation. Let's use this approach to solve this problem in front of us. Starting with adding 7, 2, 4 and 8, the output is 21. As it is not a single digit number, we'll repeat the cycle of adding 2 and 1, giving us the output as 3. With this solution, our time complexity is O of n, where n is the number of digits in the original input, and the space complexity is O of 1. I hope you were able to understand this explanation and the solution. Let's now discuss how we can optimize this solution to match the other requirement of having O of 1 runtime complexity. Another trick of solving this problem is by using the mod operation by 9. Let's apply this formula to the given input numbers in front of us and understand the pattern. After applying the formula, the output would look something like this. If you pay close attention, there is a pattern in the output. It starts with number 1 all the way to 9, which is 0, and then it repeats again. Another way to look at it is the output is actually the sum of the input numbers. So if you look at the numbers that have two digits, like 11, 12 or 13, mod operation output is 2, 3 and 4, which is also the same if we were to add individual digits in these numbers. So instead of adding all of the numbers and calculating the digits or digital root, we can simply apply the mod operation on it with number 9, which will also give us the same results. In this way, we are improving our time complexity to O of 1, as we are not processing each digit separately and instead applying the mod operation on the entire number. One edge case that we need to consider is with number 9. If we apply the mod of 9 operation, the output will be 0, which is not the same as if we were to add that digit. So if we get the output 0 after the mod operation, we need to replace it with 9. And it is not possible to have the sum of multiple digits resulting in 0. The only case that we will get a 0 is when the input itself is 0. So in which case our output should also be 0. As discussed, the time complexity of this solution is O of 1 and the space complexity is also O of 1. I hope you were able to understand this solution. Let me show you how we can implement this using C#. Here's my C# solution. I start by checking if the given input num is 0. If it is, then we simply return 0 as our output, and then calculating the sum by applying the mod operation by 9. The return value or the mod operation output is equals to 0, then I am returning 9 or else this return value variable. This solution, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 39% in terms of memory consumption. Thank you for watching this video. I hope you were able to follow this explanation and the code. The link to the code is available in the description below. Feel free to check that out and I will see you in the next one. Thank you.